So in this one, we'll be talking about prefixes and significant figures, so the mathematical prefixes that you are supposed to know and use when provided with these, and also a short sort of primer on significant figures. If you know this already, it will just be a sort of revision for you. And then you'll also get to know that, for example, when you're doing questions in A-level physics, how do you determine the accuracy of your answer? So for example, if you've done a question like a numerical, and if you've now gotten your correct answer, how do you present it to an appropriate number of significant figures? So first off, let's talk about prefixes. So there's this table of values that you need to be aware of. So this is that list of prefixes that you are supposed to be aware of. Now anybody who is into science or into technical research as such might recognize this list is not exhaustive. There are more prefixes as well, like exa, zeta, iota. All of these and these weird words are more prefixes, but these are just the ones that we are supposed to know. So tera, giga, mega, kilo, deci, centi, milli, micro, nano, and pico. These are all of their symbols. These are all of the powers of 10, which is basically what these represent. So tera means 10 to the 12, and so on. We can do this for all of these prefixes. One thing that you should observe, because it does help you memorize these powers of 10, these will not be given again, you have to memorize this, is that except for a few of these, there's a gap of 10 to the 3 in each of these. So 12, 9, 6, 3. Then these ones you're just supposed to know, it's -1, -2. Then again from the 3 to a -3, -6, -9, and -12. And also, just to relate this to real life, how do you know what each of these prefixes are? The powers of 10 are given, but if you're talking about tera, so this really means trillion. Giga means billion. Mega means million. Kilo means 1,000. Deci is 10 to the -1, and we've done uncertainty as well. So we know this is 1 over 10. So this is tenths. Centi is hundredths. Then thousandth. So 1 out of 1,000 pieces. Right? That's what this means, thousandth. And micro is a millionth. And nano is similarly a billionth. And pico being the trillionth. Right, so this is what each of these values really mean. So you should know the prefix, their symbols. Do take care that some of these are uppercase, some of them are lower cases. Aside from kilo, all of the larger ones are uppercase. Kilo is the only one which is lowercase. And then all of the other ones which basically are smaller than 1. Right, all of these would basically make a number bigger. And what I mean by that is 1 gigameter would obviously be larger than 1 meter, right? But 1 microsecond would be smaller than a second. So except for this, all the ones which are less than 1, which are basically fractional powers, all of these are not fractional powers, basically these are less than 1. So all of these are represented by lowercase except for kilo. So what you should know is obviously this, but also how to use this. So the first type of problem that you could have is writing a number in prefix form. So if you have like a normal number written, how would you write that in prefix form? Right, that's what we're going to talk about now. And the rule for this is very easy, is that whenever you want to write a prefix, so divide by the value of the prefix, and you just write that number. Right, so for example, if we have a reading some quantity which looks like this, so 514,000 seconds, right? And I have to write this in let's say 2 megaseconds. So capital M, small s, Do also take care with mega and milli, both of these are m's, but milli is small m, mega is capital M. So with this one, I know mega is 10 to the 6. So all I need to do is divide by 10 to the 6 and write it with a mega now. So for this one, I would just do 514,000 divided by 10 to the 6, which means division by a million. Decimal point is here right now. So 1, 2, 3, 4, 5, 6. So this would be 0.514. And I'm just going to place the mega next to it right now. Similarly, let's do another one with a smaller power. So this was number 1. Let's say so I have to write this in micrometers now, right? Again, let's not do micro, let's say nanometers. All right. So now if you have to do this, again, I just have to go to the table, and I won't have the table. I just need to memorize these values. This is 10 to the negative 9. So I'm just going to divide by this value now. So 0.000079 over 10 to the negative 9, which is basically the same thing as multiplication by 10 to the 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So after this you have 3 zeros. So this becomes 79,000 nanometers. Right? So this is how you can write any value in prefix form. What if you have a number if you have a number which is already in prefix form? So writing a number, or basically a quantity, in normal form. So something which is in prefix form, and you're going to write this in a normal form. For this, it's very easy. You basically just replace the prefix that you see in the quantity with the power of 10. So multiply by the value of the prefix. Again, let's do a few of these too. So for example, let's say we have So we have 0.084 teragrams, and I have to write this in just grams, right? And for this, what I'm going to do is, all I need to do, this tera, I know its value from the table. So tera is 10 to the 12. And literally all I have to do is replace the tera by its power of 10. So instead of this, I'm going to just write this as 0.084 into 10 to the 12. Right? And because this is going to be like a really large number to write out, I'm just going to write this in standard form. So 1 and 2. So I can just write this as 8.4 into 10 to the 10 grams. Right? That's also fine. In questions, it won't ever be sort of required of you to write a number in a certain prefix in a certain form. Sometimes the question might ask you to write this in a prefix form. For example, the frequency, if you're finding something in waves, maybe they could ask you in megahertz, which is why this is important. But otherwise, there won't really be such a restriction on you to either give your number, to give your answer in standard form or prefix form, or to just write this out as an entire number. But this is obviously just more elegant.
Quick pause. If you're finding value in this explanation, there's so much more to discover at Alt Academy, where we break down every A-level concept with the same clarity. Now back to the video lesson.
Similarly, if we have, let's say, So 500 micro, let's say amperes, to just amperes. Again, micro, I know that this is 10 to the negative 6. So 500 into 10 to the negative 6 amperes. Again, it's up to you. I can just take this back only as far as this so that this becomes standard form. And then I would say this is 5.0 into 10 to the negative 4 amperes, right? The third type of question that could also be asked here is if you have to convert between prefixes. So converting between prefixes. And this is important because if you think about, for example, like the SI unit of mass, which is kg. So I would always have an K in my final answer if I am working with SI units. So then I would not need to convert to grams, rather I would need to convert to kg. So that's basically a combination of both of those cases that we did above. So I'm just writing this down here. So combine cases 1 and 2. Now what do I mean by this? Let's have a look here first. So let's say I get an answer which is like let's say it's 0.045 megagrams, and if I have to write this in kilograms, right? So first of all, I need to get rid of the mega. So it's 0.045. Instead of the mega, I'll just write down its power of 10. So that is 10 to the 6. And to convert to the kg, I have to divide by its power, which is 10 to the 3. And when I do this, this becomes 10 to the 6 minus 3, which is 3. So 1, 2, 3. So this just becomes 45 kg. Right? So this is also very straightforward. Similarly, if I have to do, so let's check out another one. Let's say this is 780 milliseconds to microseconds. Right? So I have to get rid of the milli. So 780 into 10 to the negative 3. And I have to convert to micro, so dividing by its prefix value, which is negative 6. So when this negative 6 goes up, this is going to be minus 3 minus 6, which is going to make this 6 minus 3, which is going to make this 3. So 780 into 10 to the 3, or in prefix form, I could also write this as 7.8 into 10 to the 5 seconds. Now some people are also often confused with conversions between, for example, meter square and centimeter square, centimeter cube, meter cube, that sort of thing. So let's also go over that. So more complex conversions. And the way to do this is really very easy. Is, for example, you have, and this usually happens with length, because with length we deal with areas and volumes. So let's say I know that 1 centimeter is 10 to the negative 2 meters, right? So just replacing the centi value with its prefix. And I am supposed to convert, for example, centimeter square to meter square. So somebody asks me 4.5 cm square is how many meters squared, right? This is the question. Now the way to tackle this is really easy, is that you first start off by squaring both the sides, because you need a conversion between centimeter square and meter square. Right now you have centimeters and meters, so you square both sides. This becomes 1 cm square equals 10 to the negative 2 squared. So this is that indices rule, power raised to a power, powers multiply, 10 to the negative 4 meter square. So then I can obviously see that 4.5 cm square, that would really be 4.5 into 10 to the negative 4 meters square. How did I get this? Just by basically seeing that if 1 equals to this, so multiplying by 4.5 on both sides gives me this. Similarly, if I have to, for example, convert between millimeters and centimeter cubed, again, I know this for a fact, and let's say somebody asks me that I have 900 millimeter cube of volume, how would I convert this to meter cube? Again, first things first, just cube both the sides, because this time you need conversions between cubes. So 1 mm cube equals 10 to the negative 3 mm, not mm, just m cube. Do make sure that you know this, that in this one obviously you could have passed even if you didn't know this, if you did, like if you added both of these, even though that's incorrect, but I'm saying that still you had some idea it would be negative 4. But here this would obviously like mess you up. So remember that these are going to be multiplied. So 1 mm cube would be 10 to the negative 9 meter cube, right? And then for the final part, so 900 mm cube, for this I would multiply 900 into 10 to the negative 9 meter cubed. So this is what it would become, right? So this is how you basically work with prefixes, and this is asked maybe not as a separate question, but given the difficulty of questions in AS, this is probably within a certain question, so this is kind of embedded in that. Now let's talk about the idea of significant figures and how do we work with significant figures in AS. So basically, let's say you have a formula, and in that formula, let's say you are finding out something. So y equals to some formula that involves 3 variables, and those are a, b, and c, and there's some function which uses that, right? So it could be multiplication, division, addition, subtraction, raised to certain powers, but you have some equation that uses a, b, and c, and let's say we know that this is 2sf, this is 3sf, this is 4sf, right? So this is SF means significant figures. The rule is this, that the final answer must be given. So we're talking about the answer and its accuracy. So it must be given correct to the least number of SF or one more, right? So here if I look at this, what is my least number of SF, least number of significant figures? That's 2. So my answer, I can give that to 2SF or to 3SF. Usually the questions that you'll be doing in that the least number of SF will be 2. So that's why you'll also see that the examiner basically leans a bit more towards this. Instead of doing one more, so instead of doing one more SF, he just gives it to the least number of SF. So most of the answers that you'll see in the marking scheme, those would be given to 2SF. But very rarely you also have questions in which the least number of SF is 3. And in that case, your answer would be either 3SF or 4SF. And this is just my personal preference. You can think about it. You can do it according to yourself as well. But I say this, that if 3SF is common in both of those cases, so I don't want to think too much about that. And answers that I'll be writing will almost exclusively be written in 3SF. Right? So that's how you use significant figures to give your answers to an appropriate accuracy.
Hey there! If you found this A-level physics lecture helpful, why don't you head over to altacademy.org and sign up for the full A-level physics course. You can sign up for physics, chemistry, biology, math, or 4 other A-level subjects. Thousands of students have already taken the leap. What are you waiting for? See you there.